Okay, now let's talk a little bit about the pH scale. The pH scale is a way of quantifying in understandable numbers how acidic or basic a substance is. So the traditional pH scale goes from 0 to 14. However, you can have a negative pH. And you can have a pH of greater than 14. Depending on what kind of solution you have. It's just that in most of our daily work, we find that 0 to 14 encompasses most of the substances we're experiencing. Okay, so this is how the pH scale is set up. You have from 0 to 14, 7.00 is neutral. Now whenever you use pH as an answer or as a number in a problem, I want you to always use 2 decimal places. So you don't have to really necessarily worry so much about significant figures. Just use always 2 decimal places for pH. Okay, so everything to the left of this line, anything that is not 7.00, 6.99 is not neutral. That's slightly acidic. This is the acidic portion of the pH scale. The farther or the closer you get to 0, the more acidic. And from 7.00 to 14, this is the basic region. The farther you get to, or the closer you get to 14, the more basic your substance is. There's another scale that's almost exactly like pH, and that's the pOH scale. The pOH scale is set up exactly the same, except that the regions are reversed. So everything below 7 on the pOH scale is basic, and this 0 on pOH scale is the more basic region, while everything on the right side is going to be your acidic region. The pOH scale was developed to make it easy to transfer in between the pH and the pOH scales. We'll see where that comes into importance in just a little bit. Okay, so how can we calculate pH or pOH? We need to know a little bit of information about our compound that we're calculating for. So this is the formula. You're going to take the negative log of the H plus concentration. Remember that those brackets mean concentration of. So the concentration of the H plus in the solution. For all of your solutions that start with the letter H, if it starts with H, it's an acid, and the concentration of your acid is equal to the concentration of H plus. This is something I need you to write down and circle, highlight in your notes. Oh. I did a dopey thing there. To calculate pOH, we need to know the concentration of the OH ion in solution. And so in this case, if it ends with OH, it's a base, which means that the concentration of your base is equal to the concentration of the OH minus. Also something you need to highlight in your notes. Now this is a tricky formula. You're going to hit the negative sign, log, whatever your concentration is, and hit enter. all of you have different calculators and I'm not even sure what kind you're using. So what I want you to do is practice trying to find the pH of these concentrations here. So pause the tape, try to get your calculator out, and now I think for most of you, what you're going to need to do is hit, I think this is your order, I think you'll hit log, I think you'll hit negative, log, and then your number, and then equals. But I'm not sure what kind of calculator you might have. So try to see if you can get these exact answers. And if you don't get these answers, and you can't figure out a way to get your answers, you should call me on my phone immediately. I can Google your calculator if you can tell me what the exact type it is, and I can look on it and hopefully I can walk you through how to calculate pH properly. It's really important that you do this though before you even get started, because if you don't, everything is going to be totally hosed up. Okay, so let's talk about some actual, oh, I have an example. Someplace. Oh, here it is, okay. So this is slide number 26. I'm sorry I did not do them in order. Well, here we go. There we go. Oh, technology. Okay, so this is an example from your homework. It just says calculate the pH of these compounds. Okay, so here's something handy. It tells us that this is the H plus concentration right off the bat. So then all you need to do is, for showing work, write that. That's not bad. And then just put equals, and you should get pH of 2.00. I'm a little rusty on my logs. I apologize. Yep, 2. Okay. Now I put E on here because E is tricky. So let's just talk about E for a minute. Now here we have NaOH. Does that start with H? No. If it doesn't start with H, that means it's a base. We can't calculate pH. But what we can do is calculate POH, so let's go ahead and do that. POH equals the negative log of our OH minus concentration, which is that. That equals a POH of 1.00. Now I forgot to mention this before, pH has no units. It's one of the only things in chemistry that's unitless. Okay, so this is the POH, but that's not what we're looking for. Our problem tells us to calculate pH. So we have to use a formula that's on your acid-base solution sheet. It looks like this. POH plus pH equals 14. Okay, we have to use a little bit of algebra here. We need to solve for pH. So therefore, pH is equal to 14 minus the POH. We calculated 1.00 as our POH, so then pH is equal to 13.00. That was a really good example because it's very tricky. That's about as tricky as it'll get. Okay, so now that we've been able to calculate the pH, you can go back and if you know the pH, you can calculate the concentration of either your H plus or your OH minus ions. So, this is the formula for doing this. You're going to take the number 10 and you're going to raise it to the minus pH power. Now, I think for most of you, if you have a log button on your calculator, this 10 should be represented in the second log. Look for second log or shift log. on your calculator. So look to find where your log button is, and then if you hit the second key or the shift key and hit that log button again, that should show you, that should bring up a, usually this is what comes up on the calculator screen. Okay, so, we talked about that. Let's do an example of this from your homework. Okay, all it's asking us to do is calculate the H plus concentration. Here we have a pH of 1.0. So write down the formula. Oh. 10 to the minus pH. So all you have to do is write 10 to the minus 1.0. And then if you hit enter on your calculator, you should get this number. Concentration always has a unit. So on your formula sheet, what I want you to do next to this formula is write M is the unit. M for molarity. Write that, circle it on your formula sheet so you don't forget to do this. I cannot tell you how many times I instruct students to write this on their formula sheet. They do so, and then they don't put the unit. That's a half point every single time. And even this one problem on your homework, I think has like 4 or 5 parts to it. That's 2.5 points right there from not putting the stupid M on. So please make sure you do that. It's one of those attention to detail things that's just going to kill you. Okay, so let's go on to the D then. Oh, I think this problem had 4 parts. Memory serves. Anyhow, so you have a POH now. That means that here you're going to have to first, you're going to have to first use this formula to find your pH. So pH is equal to 14 minus the POH, which would give you a pH of 4.04. Then if you put that into your formula for H plus, 10 to the minus pH equals 10 to the minus 4.04. Let me give you an answer for that. And you should get 9.12 times 10 to the minus 5 molar for your H plus concentration. Now guys, it's really important that you don't forget the minus sign here. Otherwise you'll get some really wacky huge number. That's not good. Okay.